All right, next. Backpackers stopping for water to trailhead were randomly selected and their body weights and backpack weights were recorded. The data is in the table below. And then for 7, which of the following is the equation of the least squares regression line predicting the pack weight of a backpacker based on the body weight of the backpacker? So let's pull out the calculator, make sure you enter in that data, and we'll work through this on the calculator. All right, once you have your data typed in and entered into a list, for number 7, we just need to find the equation of the best fit line. So you could actually do this with StatCalc 8, or if you've looked ahead at number 8, in number 8 we're supposed to talk about evidence of whether the slope is not 0, which means we're going to need to run a LinReg t-test. So here I'm going to just do stat, arrow twice over to tests, and then I actually arrow up because it's way close to the bottom anyway. And I'm going to run a LinReg t-test. My X list is L1, my Y list is L2. And then I've peeked ahead at 8 already. Sorry to not let you in on that little secret before now. But 8 wants to know, is there evidence that the slope of the true regression equation is not 0? So in 8, I want to test not equal to 0. So I'm going to set that up right now. And then I will do calculate. And then to get my equation, I need to scroll down just one line. So my equation is y hat equals a plus bx. And my a is 16.26. My b is 0.09. So my equation would be y hat equals 16.26 plus 0.0908, or 0.091 if we round to 3 places, times x. Now when it comes to answering 8 and we want to talk about the test, we just need to go look at the p-value. Here my p-value is 0.018. And so when I look through these choices, I need to use a p-value of 0.018. So now for 9, when we want to look for the value of the largest residual, there's actually a couple ways you can do this. I think the easiest way to see which is the largest residual is to go into your lists, make sure you've run StatCalc 8 for your data. Anytime we're going to want to look at the residuals, we want to do that. And then I'm going to actually just go put those residuals into list 3. So 1, look where my cursor is. Right now it's at the top of the list. If you try and put resid in here now, you're going to get an error. It's going to make you mad. It's going to say data type. Even if you do go to, all it does is leave the cursor there. But data type really has to do with I'm putting the wrong kind of thing in the wrong spot. If I want to dump a list of residuals in, I need to highlight L3, hit second stat, and now pick resid, then hit enter one more time. And you could look at the residual plot itself. I think it's easier just to look at the numbers. I'm looking for the number that's furthest from 0. It doesn't matter if it's positive or negative. So the second one down is negative 3.2. That seems to be fairly large. Oh, wait, down here I have a residual of 3.75. That's a little bit bigger. I better keep scrolling down. Yep, that looks like that 3.75 is the largest residual. If this negative 3.2 had been like negative 3.9 or negative 3.8, the negative wouldn't matter. Largest residual just means furthest from 0. The positive or negative doesn't matter. But in this case, the largest residual happens to be positive. It's 3.75. So our Lin-Reg t-test for number 11 also tells us where our estimate for sigma is. Our estimate for sigma is S, and you got to scroll down a little bit farther, but it is there under the A and the B values that we got a little while ago. So my estimate for sigma for this data would be the 2.2695, but I think the choices are rounded to the nearest 3 decimal places, so it would be 2.270. All right, so we found on the calculator it ended up being 2.26954 and kept going. If we round the way they round to 3 places, we would want B, 2.270.